This video we're going to talk about our basic strategy for factoring, talk about grouping, and also mention a advanced factoring technique. So first off, as far as when we are factoring, you're going to follow these three steps. You always need to check to see if there is a greatest common factor. If there is one, factor it out. Then you're going to have to figure out which method to use based on your number of terms. If you're dealing with a binomial, you might be able to use a difference of squares, difference of cubes, or sum of cubes. If it is a trinomial, you can determine if it's factorable or not based off of using this. If you do b squared minus 4ac, and this value is a perfect square, then it is factorable. And then the last one would be if we have 4 terms, and we kind of check to see if it might be a perfect cube. That is a possibility. Just as the trinomial technically could be a perfect square. But if the perfect cube doesn't work, then we're just going to have to go and see if grouping will, which is the first factoring technique we're going to talk about in this video. And we've already kind of mentioned it when we were talking about how to factor trinomials. Let's say that we have this set up here. I want to factor this. Well, what I need to do, since there are 4 terms, and I can tell very quickly that it's not a perfect cube, because A, this last value would have to have a y cubed on it or be cubed itself, and B, I don't see variations here. So let's factor this by grouping. Greatest common factor of these first two is going to be an x. So we end up with 3x, because 3 goes into 6 and x there, and this will then be x minus y. And now I look at this term, so plus, and what is the greatest common factor of those two? The 5xy and the negative 10y squared. That would be 5y. And then this leaves us with our x minus y, giving us a final answer of 3x plus 5y, x minus y. Let's look at the at another example. Okay, first I scan through here. I don't see any factor that's common in all 4 terms, so I don't have a greatest common factor. Now, I'm going to group these, and yes, we could look at those two and then look at these two. And that is the way that factoring by grouping works. The first two terms have an x squared. That leaves us with 3x minus 1. The second two terms have a negative negative 4. Now, why is it a negative 4? Simple. If we pulled out a positive 4, we would be left with a plus here, and we have to have it a minus in order for us to be able to do the next step of factoring by grouping, which is to write out x squared minus 4, 3x minus 1. Now we do that third step, which is check to see if anything else is factorable. This is a difference of squares, so that means our final answer is x plus 4, x minus 4, and then 3x minus 1. Now, before I look at the last little thing I want to talk about here, keep in mind that because we are dealing with 4 terms exactly, if you want, you can always put this into the box. And we would have 3x squared, negative 3x cubed, negative x squared, negative 12x, and then positive 4. Greatest common factor of the top two is x squared. Greatest common factor of the bottom two is a 4, but because this is a minus, we put a minus by it. The greatest common factor of these, that would be a 3x. Greatest common factor of these, that would be a 1, but because this is negative, we make that negative, giving us our x squared minus 4, 3x minus 1. Okay. And then, of course, we finish factoring off this bit by turning it into that. So that's factoring by grouping. We've done it before. We did it when we were factoring trinomials. Now for something odd. Sometimes you will see something that is not factorable, or at least does not appear to be factorable. For example, this x to the 4th plus 9x squared plus 81. We see this as a trinomial, and we start thinking, okay, what multiplies to give me 81 but adds to give me 9, and we can't think of anything because it doesn't really exist. If this were 18, that would be a different story. Normally not something that we worry about or even consider, except for the fact that if we look at this first term, that's just x squared squared. If we look at this last term, that is just 9 squared. And then this has a very special property. The fact that we have this x squared here is what lets us do what I am about to do. And what that is I'm going to change this question so that it's something that we can factor. And the easiest way I can do that is if I get this to be 18. And the way I would get that to be 18 would be plus 9x squared. However, I can't just add 9x squared. So I have to then subtract 9x squared. And here you see that we have now over here we have x squared squared plus 18x squared plus 9 squared minus 9x squared. This is a perfect square. Specifically, it's x squared plus 9 squared minus 9x squared. Now, before we look at the next step, if you had, let's just say, y squared minus 9x squared, you would look at that and you would go, that's a difference of squares. And you would factor it out into y plus 3x, y minus 3x. That's essentially what we have here. So we can use the difference of squares, treating this as one term, to factor this, and would look like x squared plus 9x, x squared plus 9. That's that part. Plus this, which is 3x. X squared plus 9 minus 3x. And then this simplifies down into x squared plus 3x plus 9 times x squared minus 3x plus 9. Now, I only mention this for this reason. Odds are you will not see something like this very often. But I did want it to impress on you this fact. Whereas the normal way that we get trinomials is to multiply two binomials together, we can multiply two trinomials together and get a binomial. And that's all I wanted to point out. The fact that if we multiply these two things together, it turns into a form of a binomial, the way that we had it written, here at least. This will give us this. It's not a true binomial, but it looks like a binomial, and it acts like a binomial. That's what I'm trying to get at. Okay, that will do it for this video. Please stay safe, and I will see you